This lesson is on percent error. Percent error is something you will do quite often in lab when you have quantitative data. And this will be a part of your validity in your evaluation. So percent error is going to talk about how close you are to the correct, accurate answer. The way we calculate it is using this formula. So percent error equals the experimental value minus the accepted value. So you do that first, it's in parentheses, then divided by the accepted value times 100. The experimental value is what you do in lab. So this would be after your calculations from your data, the answer you get. The accepted value would be from a book, some sort of table, or your teacher for the right answer, the accepted one that everyone believes to be true. You will sometimes get an answer that is positive. So if your value is higher than the accepted value, so if your experimental answer is larger than the accepted, you're going to have a positive percent error. Sometimes, though, you'll have a negative percent error. This is going to be when your value is lower than the accepted value. So negative versus positive, it's just telling you if your answer is higher or lower. So let's do a practice problem, an example together. So the example says a student measured the boiling point of water to be 97.5 degrees Celsius. What is the student's percent error? So 97.5 degrees Celsius, that is the experimental value. Okay. The accepted value would be something we'd have to look up or find out. In this case, you should know what it is. What is the accepted value of boiling point of water? 100 degrees Celsius. And that is an exact number. So in terms of SIGDIGs, that number would be the same as 100.000. We could put 1,000 zeros there. So we're not going to look at that number for significant digits when we do our calculation. So we write out our problem as the percent error equals the experimental value, so 97.5 degrees Celsius. Let me correct that. And then we're going to subtract the accepted value, so 100. And that's in parentheses, so we do that first. And all of that is going to be divided by the accepted value, so 100. Okay, and we are going to multiply by 100 because that's how we calculate a percent. So in doing the first part in parentheses, 97.5 minus 100, you get negative 2.5. So I'm going to actually write my steps out here. So on the top, negative 2.5 is going to be divided by, sorry about that, negative 2.5 degrees Celsius divided by 100 degrees Celsius. Okay, and we're going to multiply that by 100. So the top number, notice I kept it negative 2.5. The 0.5 is one digit after the decimal. Well, I have 97.5. That has one digit after the decimal. The 100, remember I said, has infinite number of zeros. So we're just going to look at our experimental value for this one. So in subtracting, we keep the lowest number of decimal places, which is 1. So that's the same number. So now we're going to divide by 100, and then we're going to multiply by 100. Dividing by 100, multiplying by 100, you're doing the opposite, so that will cancel out. So your answer is negative 2.5. We have two SIGDIGs, the same as before, percent. So what does this tell us? Well, the negative tells us that our answer was lower than the real answer. The 2.5% tells us we are 2.5% off of the original answer. A percent error is good, the smaller it is. So the perfect percent error, a perfect lab, would be 0%. The worst would be 100%, or higher actually. So you want a low percent error. And that's something in your evaluation that you should discuss. What is your percent error and why did you get that? At this point, you should do the learning check. The practice problem is in your notes packet.